Hi guys, welcome back to my math YouTube channel. In my previous two videos, I introduced the concept of complex numbers briefly, and we also looked at how to plot a complex number and then also how to find the absolute value, which is simply the distance of the complex number from the origin. Now guys, we want to introduce this idea of the connection between the complex number and the trig functions, and we want to see how we can transform from a standard form of a complex number to a trig form, and that trig form is also called as the polar form. Okay, so polar form, or you can call it as a trig form. Now, it is not too difficult to actually see the connection once we understand how to plot a complex number and the idea of an absolute value. Guys, let us go back and start by looking at the standard form, which is a plus ib. Again, I am assuming that a and b are both greater than 0. Guys, it is going to work for any value of a and b, any real value for a and b, whether it is in the first, second, third, or fourth quadrant. It is going to work anywhere, but it is easy for us to actually analyze these things in the when both the quantities are positive, which means they are going to be in the first quadrant. So if I have to plot this, we already know this is my real and this is my imaginary part, and I can think of that as a coordinate pair a and b. And if I want to plot this, this is my horizontal axis, which is also called as the real axis here, and vertical axis is called the imaginary axis. And if I plot this a and b, guys, obviously they are both positive, so they're going to be in the first quadrant. So if let's say they're right here, then what I'm going to do is I'm going to connect this line between the origin and that point, which is represented by that complex number a plus ib, or you can write that as a coordinate pair. And then guys, what I'm going to do is I'm going to drop a perpendicular from this point onto the real axis. And guys, you can already see, since we want to see the trig connection with trigonometry, guys, there's two things that we need. We need to have a triangle. So at a triangle, what are the two things that are connected to a triangle? One is the angle, and the other thing is the sides, right? So once we have a complex number, in order to see the trig form or the trig connection, one has to create a triangle. And in this case, it makes sense, or it becomes easier if we actually plot, or if we draw a right triangle. And we can easily draw a right triangle by dropping a perpendicular from here onto this horizontal axis. And when we do that, what we get is a right triangle. Guys, this is 90 degrees. We already know that this horizontal length is a and this vertical length is b. This is my r, which is also like the absolute value, or in context to the right triangle, it is the hypotenuse of the right triangle. And guys, these two, we kind of think of them as the legs of the right triangle. Guys, I also like to think of this as the base, this as the height sometimes, right? Now, in order to actually see the trig connection, we just have to introduce one more thing, which is going to be the angle. And guys, let us call this as angle theta, which we can also sometimes think as the reference angle. Guys, I mean, I'm sure you have been watching my other videos and you have already covered a lot of different sections in the trig course to get to this point. So you already know that angle. We usually call that as the reference angle. So we have the angles, we have the sides, we have the hypotenuse, which we know is represented by r, and if we have to actually calculate it, it is going to be square root of a square plus b square using the Pythagorean theorem. Okay, so guys, now let us just focus on this right triangle and try to see if there is a way that we can use this right triangle, which basically is actually giving us the complex number in the standard form a plus ib. Now, how can we use this to transform this information into the trig form? Guys, not too complicated. We have a nice right triangle. Let us do this. Let me first rewrite the standard form, which is a plus ib, right? Now, guys, we want to convert this into the trig form. We want to convert this into the trig form, or what we also call as the polar form. In order to do that, obviously, we need to have some trig functions, sine, cosine, tangent, or whatever, right? Any of those 6 trig functions. Obviously, it will also involve angles. In this case, we call it theta, so it is definitely going to involve theta. Now, what I'm going to do is, here guys, in this triangle, let us actually start by writing some trig functions. Let us start writing the basic ones. For example, let us say we don't know anything about the transformation from standard to the trig form. So what are we going to do? We're going to just start by writing some basic trig functions, and the most basic ones are the sine and the cosine. So I'm going to start by writing the sine and the cosine for this particular right triangle and see if that is going to help us to transform this or rewrite this in the polar form. Let me start with the sine theta. Guys, what is the sine theta? We know the definition for the sine theta in context to a right triangle. It is the ratio of the opposite over the hypotenuse. What is the opposite? Opposite to the reference angle theta is B. So it is going to be B over hypotenuse is represented by R. Okay. Guys, if I have sine theta as B over R, from here, if I cross multiply, what do I get? I get B equals to R sine theta. Right, b equals to r sine theta. Let us preserve this. Now let us go up to the next. Trig function. The other basic trig function is the cosine theta, and we know cosine theta is the ratio of the adjacent over the hypotenuse. My adjacent here is a, and hypotenuse is r. From here, guys, if we cross multiply, we get a equals to r times cosine of theta. R times cosine of theta. That's good. Let us preserve this as well. Now, if we go back to the original complex number represented in the standard form or in the general form, guys, what we can do here is we can replace a by r cosine theta, and then, well, I will stay, and we can replace b with, we already have b in terms of the sine theta, r sine theta. And guys, this would be called the trig form. Why can we call this a trig form? Because it has the trig functions cosine and sine, and r obviously is the hypotenuse, or you can also think of that as the absolute value of the complex number. So guys, this guy is called the trig form or the polar form. Now you may, or one may be also able to use the tangent function to actually rewrite this standard form into a trig form. But guys, if we try to do that, it is going to be slightly more complicated. But can we use other trig functions to rewrite the complex number from standard form to trig form or polar form? Yes, guys, we can do that, but that is going to be a lot of extra work. This right here, using the basic trig functions, sine and cosine, is like the easiest one, and we always like to start with the simple basic trig functions, sine and cosine, because those two are the building blocks for rest of the other four trig functions, namely the tangent. Guys, tangent, we can get tangent by taking the ratio of sine over cosine. Then comes the cotangent. Same thing, we can get cotangent by taking the ratio of cosine over sine, then cosecant, which is the reciprocal of sine, and then secant, which is also reciprocal of the cosine. So we can get all of those once we have the sine and cosine. In this case, we were already lucky to get b and a in terms of sine and cosine. So why try to go to tangent and other complex trig functions when sine and cosine does the job for us? So guys, once we plot it and then we try to write some trig functions, basically the basic trig functions, we could easily convert this standard form a plus ib into a polar form or a trig form, which looks like r cosine theta plus I times r sine theta. Guys, sometimes people like to write it in a slightly different way, which is like r and r is a common factor. So people like to take out the common factor, and then what is left inside is just the cosine theta plus I sine theta. So both are correct. It's two different ways of writing the polar form or the trig form. Okay. So guys, this is the connection between the complex numbers and the trig functions. Now, what we need to do from here is, guys, in examples, we will be provided a complex number in the standard form, where a in like a plus ib form, and we will be asked to convert it into the trig form, which means something that involves sine and cosines. Okay, and we will also be asked to go from the trig form back to the standard form. So if you can go from A to B, there should be a way to go back as well from B to A. So in my next video, guys, I'm going to start doing some examples where we transform the standard form, which is represented by A plus IB, into a polar or a trig form. Guys, these things are important, not just only for the trig class, but they are very important for other advanced math classes. So that is other reason why I actually want to spend some time on these concepts and show you different examples. Guys, till I start doing these things in the next video, you guys take care. Just try to look at this basic connection between the polar and the standard form, and I will see you next time with some examples. Okay, till then, take care.